Today we're talking about exponential equations and logarithm equations both. So this one's going to be a fairly lengthy one just to make sure that we cover all the material in it. And at points we'll ask you to pause it so you can work on some problems, make sure that you understand the material, and then you can restart it. So first thing that we want to do is go back in and do just a little bit of review. If we go back to this one, we need to be able to convert from exponential form to logarithmic form. So I'm going to ask you to do these right now. Pause this, that way you can do your work and then you can check it. Okay, hopefully you came up that your answer should have been in this form. Notice that the base of the logarithm is 5, the base of the exponent is 5, whatever's on the right hand side of the equal sign turns into the exponent, okay? And same thing down here, this one's just going into from exponential to logarithmic form. 16 is my base, that remains my base of my log. This y moves on to the other side of the equal sign here. Okay, I'm going to give you another one to try out. Try out this one and just push pause here. Check your answers to make sure that you got the right answers. Okay, now we're going to move that on. We're going to move on from there and start using it in equations. So let's give you an example. With this particular one, we want to put it. It's written as a logarithm, and we want to convert it to exponential form. That will help us to solve this equation. So if we rewrite this one in exponential form, 9 is going to be my base, x will be my exponent, equals whatever this part is right here. In this case, it's 9 to the 5th power. Well, you can quickly see here that if we have the bases are the same, it's equal to each other, that means their exponents have to be the same. Okay, and if their exponents have to be the same, then x has to equal 5. So here we have our x equals 5. Now I'm giving you the next one here. Go ahead and try that one to make sure that you put it in the right form. The key is to write it in exponential form first. Then you can try to solve it. So do that now. Push pause. Okay, and check your answer. Make sure that this was the one that you've got. Remember, 2 to the 3rd power is 8, but this one's 1/8, indicating that this exponent has to be negative. Okay, let's try a couple of these. We're going to give you some easy ones at first. And try these two. And just push pause. Okay, check your answers to make sure that you've got these. Hopefully, and these are fairly easy. You can almost do these in your head, but I want you to get the practice of writing them in exponential form. That's really going to come in beneficial for the next problems that we end up doing. Try these two. And check to make sure that your answers are correct. Okay, this is kind of the end of the easy ones. Now let's try some that have a little bit more challenge to them. You're going to use the same method that you were using before. You're going to convert them to exponential form first. So here are your problems, and you want to convert them to exponential form first, okay? So just push pause when you're ready. Okay, check your answers to make sure this is what you got here. And both of these ended up being okay. They're not too bad. Remember that it's x divided by 8. And when it's x divided by 8, that means we're going to multiply both sides here by 8. Okay, so now let's go to one that you haven't quite learned yet. This particular one is one that we've done in the past where we combine these, but now it's set up as an equation. So we're trying to determine what our value of x is. Well, the very first step that we're going to do on these is combine these two, the ones on the left-hand side. Notice that they both have a log base 4. So when they both have a log base 4 and it's addition in the middle, that means that we can condense those into one logarithm. This would be a log base 4 of 7x equals 3. Remember, the addition turns into multiplication. Well, now that we have this, we're going to use the same thing that we were doing before where we convert these to exponential form. So we'll do that now. This will be 4 to the 3rd equals 7x. Now we just need to simplify the left-hand side. 4 cubed is 64 equals 7x. So we want to divide both sides here by 7. And then we just need to round our answer. This one asks us to round it to the nearest thousandth. That's going to be 3 decimals. So we'll go ahead and write that as our answer here. So now let's get some practice problems here. Let's start off with these two. Go ahead and push pause whenever you're ready. and check your answer to make sure that you got the answer that you were hoping for, hopefully. And the same thing here, we're just condensing those. Remember, this one is subtraction, so it's going to be division on this side. This one is real close to our previous example that we had. Let's try another problem just to make sure that you understand it. Just push pause whenever you're ready. Check to make sure that you got the right answer on this one. This one seems to trouble students at times because this negative here, a lot of people thought that it was subtraction. Well, this is addition sign here. This is log base 6 of 9 plus log base 6 of negative 3k. So this is still multiplication. We're going to end up multiplying 9 times negative 3k for a negative 27k. Okay, that was the main trip up on that one. Okay, let's move along now. On this particular one here, we're trying to determine what x is. And we've got this one, and this is a little bit different. We've got the base of this is 5. This is all in the exponent, log base 5 of 17. Okay, so what we're going to do here is we're going to rewrite this one in logarithmic form. And that sounds kind of weird. But we will go ahead and convert it in. When we write it in logarithmic form, remember that this portion here, that is your exponent, will go on the right hand side of the equal sign. That's a big key component. The left hand side of the equal sign will be this log base 5. That 5 comes down here. That's where I got that 5. X here came from this side. This comes on the other side. And remember that this exponent will go on to the other side. So that's what it looks like here. Now, if you identify here, we have a log base 5 on both sides. We can basically just cross those two off, because that will just leave us with essentially x and 17. So our answer here is x equals 17. So the shortcut behind this one here is if you can just remember that we just cross, anytime you have one like this that's got an exponent, or excuse me, got a base of an exponent and the base of a logarithm in the exponent, that's the same. This one's both 5. We can just cross those two off, and whatever it is this, whatever we're left over with is this number right here. For instance, let's look at this one. Here I have a base of 7, and in the exponent I have a log base 7. So I've got my similar setup here. They had the same numbers, so I can just basically cross these off. This will tell me that b will equal 32. Okay, I'm crossing those off. I find out that b does indeed equal 32. Okay, so now let's look at a little bit, some other ones so we can get a little bit of practice. Why don't you try these two and just push pause when you're ready. Okay, and check your answer. And again, you can convert them both to logarithms. That's the long way to do it. The short way to do it is to identify that we have both of these two have the same base, both of these two have the same base. We can just basically cross those guys off. So this one simplifies to 8, and this one simplifies just to plain old k, and so k equals 12. All right, now this one we want to go through. This one is an exponential equation. And the way that we're going to solve these, there's a couple of ways, some that are really easy, but they don't really work for the hard one. So I'm just going to teach you a way that will work for everything. Okay, when we do this one, what we want to do, the problem is that we have this k in the exponent. So we want to be able to identify what k is, but it's kind of hard to tell there. I mean, 15 to the first power is 15, and 15 squared is 225. So it's somewhere we know between 1 and 2, but we have no idea what it is. And this one asks us to round it to the nearest thousandth. So the way that we're going to solve this one is we're going to actually take the logarithm of both sides. So the way we do that is we basically just add the word log onto both of them right in the beginning. Now this is log 15 raised to the k power is equal to log 36. And we basically just wrote the log in front. We wrote it, this is, both of these are base 10. And the reason why we're using base 10 is because it's on our calculator that way. The calculator has the log base 10, which makes it nice. Okay, so we're going to take this one now. I'm going to take this k here, and I need to move this here. I don't want to have it as my exponent. Well, what we can do here is we can move that in the front. Using our laws of logarithms, law number 3 that we covered, we can move that k right out in front. So if we simplify it a little bit further, it's k log 15 equals log 36. And so this is k times log 15. So the very next step that we're going to do is try to get k all by itself. Because this is k times log 15, we're going to end up dividing both sides by log 15. So we'll do that now. Okay, so if we divide both sides by log 15, we find out that k equals log 36 divided by log 15. Now we want to plug that into our calculator. So let's take out our calculator here. Let's clear this all out. Okay, let's pull it up just so we can see our calculator just a little bit better. And I'm going to type it in exactly as I see it here. I just type in log, and it automatically opens a parenthesis. We're going to go 36, close my parenthesis. That's going to be vitally important. If you don't close your parenthesis, we'll get the wrong answer. So then we're going to go divided by log 15. Close the parenthesis, and just hit enter. And here's our answer right here. Now this one asks us to round it to the nearest thousandth. Thousandth is 3 decimals, so that'll be 323. Right here, 1.323. So we need to move that over here. And then just simplify it. We plug that into our calculator. Here is our answer. K is equal to 1.323. And we've got these little bacon strips, if you will, these little swervy lines. That just means that we've approximated it because we've rounded it. Okay, so it's not exactly equal to that, but it's pretty close because of when we're rounding to the nearest thousand, that's pretty close. All right, let's look at another example here. This particular one, again, is really similar to the one that we just did. The one that we just did had one component in our exponent. This one has two. It's got a p and a plus 7, but we're going to solve these the exact same way. So let's start on this. So we've got, the first thing we want to do is take a log of both sides. So that we basically just add our log in front. And what you do to one side, remember you have to do to both sides. So this side is also going to be a log, and then we're going to add a log to it. So we've got to get rid of this p plus 7. This is in the exponent, so we're going to have to move that guy out in front. So we move that out in front. Notice my use of parentheses here. When I move it out in front, I'm multiplying this entire quantity, p plus 7, times log 19. Okay, so it's important that you put the parentheses around it. That becomes important because the next step is we're still trying to get p all by itself, so we're going to divide both sides by log 19. So we divide by log 19. That simplifies a little bit to p plus 7 is equal to log 8 divided by log 19. Okay, so we need to figure out what log 8 divided by log 19 is, so we're going to plug that into our calculator. Let's bring our calculator back in here. Okay, so we've got log 8, don't forget to close your parenthesis, divided by log 19. Close your parenthesis and hit enter. And it gives you this answer here. On the screen here, I'm going to round it just because I don't have enough room. But realize I would not round this, would not round it at all until the very end, otherwise you risk getting the wrong answer. Okay, and then over here on the left-hand side, we're still trying to get p all by itself, so we're going to have to subtract 7 from both sides. So when we subtract 7, let me bring back in my calculator. All I need to do here is just hit minus 7. Notice I did not round this, I just left it in there, and I just hit minus 7. I'll hit enter, and that gives me my answer here. Now at this point, this is my answer. Now I can round it to the nearest thousandth, which is 3 decimals. So I'm going to write that, round it to the nearest thousandth, and there's my answer for me. Okay, now, we're going to try a couple here, so let's try these here. Here are your first two that I want you to try. Just push pause when you're ready, and then you can work on it, and then you can check back in for your answer. Check to make sure that you got the right answer here, and hopefully that you rounded correctly on both of these. Both of these asked for the nearest hundredth. Remember, when you're typing it into the online system especially, it will mark you wrong if you don't round it correctly. Okay, but check to make sure both of these should be pretty good for you. Let's try another 2 here. And hold on a second, we'll bring it in. And here you go. Okay, so I want you to go ahead and solve these. And this one seems a little bit different because it's got this e here. So keep that in mind. You can still use the log base 10. You just take log base 10 of e. Or if you use ln, make sure it's ln of e. So you're going to still have the e written there. Okay, it's a ln, which is basically log base e. So it's going to be essentially log base e of e whenever you use the ln, but that'll be fine. So push pause when you're ready and try these problems out. And check to make sure that you got the right answer here. Now you'll notice here, this one looks like I kind of skipped a step because I moved my m over and then I divided both sides by log base e, which is kind of true, but when you start using these enough, you'll identify that log e is really 1. If you type it in your calculator, just go log e, and when you're typing this into your calculator, in fact, let's bring in the calculator, we'll do that right here. If I go ln e, and e is, remember, is your second ln button, second ln, and it says e to the something power. This is definitely e. When I move my m onto the other side, this will be e to the first power. Okay, so if you do that, then you find out that ln of e is just 1. Okay, so essentially we moved our m onto the side. This is m times 1, which is just m. So I didn't really need to do that. That was kind of a shortcut. If you did this and you took a log base e of both sides, that's just fine. You should have obtained the same answer as well. It doesn't matter whether you use ln or whether you use log. But what is important is that when you use your ln, you use it on both sides. You don't want an ln on this side and then a log on this side. That will not work. That will not get you the right answer. Okay, let's try another one here. And this one's going to be important here. A key thing to be aware of here is this 7. We're going to have to subtract 7 from both sides very first before you take the log of both sides. So go ahead and try that one. Push pause when you're ready, and then you can come back to it to check your answer. And check your answer to make sure that you got the right answer on these. Hopefully you're starting to kind of get the hang of these. Now I want to kind of switch gears a little bit and go back in and do another problem here. Skip that one. With this particular one, we want to condense the ones on the left-hand side. So these are both have a log base e, ln, natural log, if you will. So and its addition here means we're going to combine them by multiplying these two together. This is going to be 3 times h. So 3 times h, that one will simplify to ln 3h is equal to ln 57. Now because we have the log on both sides that has the same exact base, e, we have a natural log on both sides, I can basically just cancel those two out. They can just disappear, if you will. So that would yield us, simplified even further, the 3h equals 57. Now I just solve it like I would any other equation. I divide both sides by 3. To get h all by itself, I end up finding out that h equals 19. Okay, now I want you to try one. And I'm going to leave this one up top here just as a reminder. Here you go, try this one, and the way, remember that we're just going to combine what's on the left-hand side, combine what's on the right-hand side, and then get rid of our log, because these are all log base 4. So push pause when you're ready, and then you can come back and check it. Hopefully this is what you got for your answer. 15.4 should have worked for you. Okay, let's try this one. Start working through this one right now, and then push pause when you're ready. Okay, hopefully this is what you got for your answer. Hopefully that worked out the way that you wanted it to. Okay, and that concludes this particular lesson. If you want some extra practice, you can go back through and just repeat these ones to get a little bit extra practice. But you can go ahead and start your homework at this point.